Hello everyone, welcome back to another video. So we were practicing top interview 150 questions. It's been a while since we last did a question, so let's back into the flow. Today we will do two sum input array method. So we know that the two sum is a very famous question. So let's read the problem statement. Given a one index array of integer that is already sorted in non-decreasing order, find two numbers such that they have to a specific target. The test are generated such that there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. Okay, so the problem is same, that we have to find two numbers that sums up to target. But in this case, we are given that the array is sorted and we have to use only constant extra space. So in the two sum problem, we used a hash map to store the number and the position, and we return if we find a complement of a number that sums to the target. But in this case, we have to only use extra space. So let's just dive deep into it. We can use Excalibur. Okay, so the main hint is that the array is sorted. So that means like it will be in the increasing order, and we can use a pointer, basically two pointer. So I and j. Okay, I will be at the start and j will be at the beginning. And since we have to use only one constant space, so we will use a not answer, let's say total. Okay, total, or let's say sum will be a better variable name. Okay, now let's start from beginning. And our target is whatever is the target, 9. Okay, so our target is 9. Now like we have the I and j index at the start and beginning. If we sum this, we will get 17, which will be the greatest, like not greatest, but it's the extreme case. That okay, we have like since we are guaranteed that there will be a sum, so that means this is the window, right? So 2 plus 15 is 17, which is greater than 9, right? So we have to reduce the j, because since it's a greatest, so let's reduce from the n, so that we get like another, so we get that we reduce a bigger number. So now what is 2 plus 11, it's 13, which is still greater than 9. So reduce j. What is 2 plus 7? It is 9. So we got the number, we return the number. Got it? So like let's take another example. Let's take our target is 7 plus 11, 18. Okay, so we start from I, we start from j. 2 plus 15, 17, which is smaller, right? Now since we have to make this bigger, we have to increase I, because since it's a increasing array, if we move I, then you'll obviously get a smaller number. Now 7 plus 15, it is 22. That means it is 22, which is bigger. Okay, now we have to reduce this sum, so that means we have to move j. Now the sum is 7 plus 11, 18, and the index at which I and j is present, that is the answer. So let's implement it. We will have int I equals to 0, j will be numbers dot length, and while I is less than j, we will have a sum of nums I plus nums j. Okay, now we will have three conditions: either sum will be equals to target. In that case we will return an array of I plus 1 j plus 1. We are doing a plus 1 because we have to return it in the one index array. So if I is at, in this case, index if it is a 0 index, then I is at index 1, but we have to return it in a one index array, so that means this index will become 2 and this will be 3. So therefore we are doing plus 1. So either sum will be equals to target, else if sum will be less than target. So what if sum is less than target? So if let's say target was 18 and sum was 17, that means we have to move I, that only the sum will increase. So I plus plus, else means sum is greater than target. If it is greater than target, we have to move j, then only the sum will decrease. That means j minus minus. That's it. If we are guaranteed that a solution will be present, so we will definitely hit sum equals to target. And for this, for the return type, we just return a dummy array, let's say -1 -1. This will never be hit, okay, but it's just for the like syntax we are writing it. So let's just try to run it. Okay, something is wrong. Okay, so it's not nums, it's numbers. Okay, so something is wrong. Okay, so it's numbers like -1. Yeah, awesome. All the test cases are passing. Let's try to submit it. Perfect. So it's getting accepted. So it was a two sum problem, so we just have to maintain a window, and if the sum is greater, we have to just reduce j so that the sums get decreases. If the sum is smaller, we just have to increase I so that the sums get bigger, and ultimately we can find the 2 index. So that's it. See you in the next video. Thank you.